Alright, let's talk about a special case of factoring trinomials. That is something called the difference of two squares. So to start in, let's jump right in and let's look at sort of the math speak of what it means to take the difference of two squares. It's a special case that when b equals 0, you can do a difference of two squares. That is to say that if b equals 0 and both the ax squared and the c term are perfect squares, then we can factor ax squared minus c into the square root of ax squared plus the square root of c times the square root of ax squared minus the square root of c. Sounds hard, doesn't it? But the truth is, it's really not. And let's walk through some examples and sort of remind ourselves what all these special terms mean, and I think you'll see this is actually really easy to do whenever you have this special case. So, the big question, what's a perfect square again? Well, a perfect square is one of those numbers that when you take the square root of it, you get a whole number. So, perfect squares are any number that you take the square root and you get a whole number back. So, for example, the number 4 is a perfect square, because if you take the square root of 4, you get back 2, a whole number. 5 is not a perfect square, because the square root of 5 is not a whole number. It's actually a decimal. So other whole numbers that are perfect squares might be, for example, 9, because if you take the square root of 9, you get the whole number 3 back. And in fact, there's a classic set of perfect squares, and those are the numbers you get when you look at your multiplication tables. Think about it like this. If you take your whole numbers starting at 1 and multiply them by themselves, or square them, you'll get a perfect square. For example, 1 times 1 is 1 squared, which is equal to 1. So this number, 1, is a perfect square. 2 times 2 is 2 squared, which is equal to 4, which means that 4 is a perfect square. 3 times 3 is 3 squared, which is 9. 9 is a perfect square. And it goes on until you get this entire list. All of these values here are perfect squares. These are the perfect squares of 1 through 12. And while any number that you can take a square root of and get a whole number back is a perfect square, the ones we're going to run into most often are those of 1 through 12, or 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. So let's go back and look at that definition again. Special cases. When b is equal to 0, you can do the difference of two squares. If b is 0 and both ax squared and c are perfect squared, then we can factor ax squared minus c into this enormously long gobbledygook, the square root of ax squared plus square root of c times square root of ax squared minus the square root of c. I think we can simplify that. So let's do this. Let's just sort of shrink this one down, move it up out of the way, and let's sort of tackle it in pieces. First of all, what does it mean to have b equal to 0? Well, that's pretty straightforward. It just says that if we have some trinomial, ax squared plus bx plus c, it just happens that the value of b is 0. So it's kind of like saying we have ax squared plus 0 times x plus c. Well, what's 0 times x? It's 0, isn't it? And so we just eliminate it from the problem, and we get ax squared plus c. Okay? So that's what it means when b is equal to 0. But in this case, there's another part of this. That is that it's the difference of two squares. And if we go back into our math speak, we can remember that the word difference in math is the same thing as subtraction. So we always know now that not only do we have to have just ax squared and c, but we also have to have subtraction. So instead of ax squared plus c, what we're really looking for is ax squared minus c. Whenever we have this layout, we know we can do difference of two squares. And then the final caveat is that both ax squared and c have to be perfect squares. Now, we talked about perfect squares, and so it should be pretty obvious that a and c just have to be numbers or integers that are perfect squares. So for example, if a was equal to 4 and c was equal to 16, you know that these are both perfect squares. Okay, they're just perfect squares. And that way you know that they work. But what about x squared? How do we know if x squared is a perfect square? Well, in this case, we just have to think about what happens when you take the square root of x squared. To get x squared, you have to have x times x. So if you take the square root of x squared, you're just looking for what value times itself will equal x squared. So the square root of x squared is x. Any value of a variable raised to a power that can be square rooted works in this problem. So for example, if you had x to the fourth, well, the square root of x to the fourth is x squared, which we consider a whole number. So that'll work as well. Same thing with something like x to the eighth. If you take the square root of x to the eighth, it's x to the fourth. And that works as well. So you can keep doing this anytime that the variable is raised to one of these even powers that can be divided in two. So let's go ahead and let's really look at some examples that's going to make all of this math speak look really, really simple. Alright, so I've got 3 examples here. Let's go ahead and let's start with 9x squared minus 16. So when we talk about this, first things we need to look at are our values of a and c. Are they perfect squares? In this case, 9 and 16 are both perfect squares, and x squared is also a perfect square. Okay, next up, are we talking about a difference? Well, we have subtraction, so we're good there. We have a difference of 2 squares. So, let's figure this out. We need to find the square root of ax squared plus the square root of c and multiply it by the square root of ax squared minus the square root of c. Well, let's dig this apart into different pieces. So I'm going to set up my parentheses. I'm going to put a plus there. I'm going to put a minus there. And now all we have to do is sort of figure out what is everything going for. So, what is the square root of ax squared? Well, our a term is 9x squared. Let's break it down even further and just look at our coefficient of 9. What's the square root of 9? Well, that's 3. Let's look at our variable. So we have x squared. We talked about the square root of x squared is simply x. So there we go. The square root of ax squared is just 3x in this case. If we look at c, we're looking for the same values. c is 16. The square root of 16 is 4. So we can just drop a 4 right in there. That's it. We're done. 3x plus 4 and 3x minus 4. It's so much simpler than that old definition makes it seem. Let's do another. So here we go. 25x squared minus 81. Once again, I'm just going to go ahead and set up my parentheses. I know one of them has to be a plus, one of them has to be a minus. So break it down again. Our first value in ax squared is 25. The square root of 25 is the value 5. If we look at our next value, x squared, the square root of x squared is just an x. And finally, the square root of 81, or our c value, is 9. Boom, we're done. Super simple, isn't it? One last example before we move on. Set up my parentheses. We know that one has to be positive, one has to be negative. The square root of our first term, 64, is 8. Square root of our second term, x squared, is just x. And the square root of our c term, 121, is 11. Once again, we're done. Super simple. It's just a matter of finding the square roots of each of the individual parts. The hardest part is simply to remember that you have to have ax squared minus c in order for this to work. It doesn't work if it's ax squared plus c. The last question that we always get asked is, well, why do you always put the plus first and the minus second? Does it matter if I switch it around? And the fact is, it doesn't. You could rewrite this as 8x minus 11 times 8x plus 11, and it will have no difference on your final answer. So write whatever works best for you. Let's look at two more examples where there's a little more to it. Not much, but just a little. So here are two examples with a little more to do. In this case, we'll start with 16x squared minus 36. We're going to start off just like we did before. We've got our parentheses. One's positive, one's negative. Square root of our first term, 16, is 4. Square root of our second term is x. And the square root of c is 6. So, now we've got 4x plus 6 and 4x minus 6. And you might notice that 4x plus 6 and 4x minus 6 share certain values. In fact, there's a 2 shared in both of those parentheses. So in order to finish this problem, we're going to go ahead and factor that 2 out. In this case, 4x plus 6 shares a 2, so we'll pull a 2 out. 4x divided by 2 is 2x. 6 divided by 2 is 3. And we're going to multiply that by our second problem. Once again, 4x minus 6, they both share a 2. 4x divided by 2 is 2x, and negative 6 divided by 2 is negative 3. So now we get 2 times 2x plus 3 times 2 times 2x minus 3. There's one last step. Because these have the same value in front, we can go ahead and pull them out and multiply them. So we can really say it's 2 times 2 times 2x plus 3 times 2x minus 3. In this case, 2 times 2 is obviously 4, so what we get is 4 times 2x plus 3 times 2x minus 3. And that there is the final answer for 16x squared minus 36 using the difference of two squares. Let's do one last example. 36x squared minus 144. We're going to go ahead, start it out exactly the same way. Square root of 36x squared becomes 6x. And the square root of 144 is 12. And once again, one of them's positive and one of them's negative. In this case, we want to look at what do each of these share. And in this case, they both share the numeral 6. So we'll factor that 6 out. 6 times what? Well, 6x divided by 6 gives you x. 12 divided by 6 gives you 2. And we're going to multiply that by 6 factored out of 6x gives you again an x. And negative 12 divided by 6 gives you negative 2. We're once again going to multiply our two leading coefficients. So 6 times 6 gives us 36. And we'll multiply it by our remaining factors. In this case, x plus 2 and x minus 2. Right there is our final answer. So remember, as we're looking at this, what you're really looking for is a couple of key phrases. Number one, do you have a difference of two squares? That is, you have ax squared minus c, where both ax squared and c are perfect squares. That is something where you take the square root of some number and you get back a whole number, not a decimal. As long as this is all true, then you can go ahead and use that shortcut of finding the difference of two squares.